localizer, glide slope, another is marker beacon. So these components are having individual functions, same way as we have discussed regarding the washing machine. है ना? The the drum is having a function to hold the water, the content. The motor is having a function to rotate the drum to wash the content. The control panel is having function to set time. Body, that function is to hold the whole system. Same way, ILS, instrument landing system, it is having three component: localizer, glide slope, as well as marker beacon. Localizer. Localizer function is to give azimuth guidance. So what you understand by azimuth guidance, guys? It is a horizontal guidance. Horizontal. Taking reference from the runway center line, it will guide you how much left you are flying from the runway center line or how much right you are flying from the runway center line. That is called azimuth guidance, horizontal guidance. That is the function of localizer. Localizer does the function azimuth guidance. So sitting in aircraft, how you will come to know? There is an indicator. This whole is called ILS indicator. There is a vertical bar plotted against a horizontal scale. This is indicating, this bar is indicating that you are left from the center line, runway center line. This vertical bar indicates the azimuth guidance. It gives the azimuth guidance. Is it clear, guys?
Yes, sir.
Okay. Yes, sir. Now coming to the, so we are clear about this function of this localizer, right? Now coming to glide slope. So
तो लेकिन लोकलाइजर कैसे कैसे पता चलता है कि मतलब हर रनवे के तो अलग अलग सेंटर लाइन रहेगा ना हर जगह।
डेफिनेटली हम उस पे आएंगे। अभी मैं आपको इसके फंक्शंस बता रहा हूँ, कैसे करता है वो बता, हाउ इट डज। फंक्शंस यही है, अलग अलग एयरपोर्ट में अलग अलग रनवे रहता है, उसका फ्रीक्वेंसी अलग रहता है। नाउ glide slope. This glide slope works, the function of the glide slope is giving elevation guidance. Elevation means from the glide path, correct, vertical guidance. From the glide path, how much above you are or how much below you are flying. So definitely all the aircraft, they come in a particular angle for landing. So we have the same indicator having one more needle to indicate the elevation guidance, horizontal, vertical guidance. So how much above or how much below you are from the glide path. So now this is indicating you are a little bit below the glide path. So this horizontal indicator working or placed against the vertical scale to indicate how much above or how much below you are from the glide path. Now we are understood about the function of two things, localizer and glide slope. It is very easy, Ajay, very easy it is.
Yes, sir.
Just need to focus.
Yes.
Two functions. ILS is a system having three components. They have their own functions. Localizer is doing azimuth guidance. Glide slope is giving horizontal guidance. Elevation guidance, vertical, correct. Now coming to the marker beacon. Marker beacon gives discrete distance indication. Discrete distance. What do you understand by discrete signals? See guys, there are three types of signal in aircraft we use. One is called analog.
One is digital.
Digital. Another is discrete. Discrete means either on or off. Digital means there will be a particular on off continuous things will be there, on off, then stop, then on off, like binary 0101. Analog is a straight, so it is having a scale, continuous, it will be go. Example, Ajay, discrete signal. Suppose you switch off the lights, the light will go off. That is a discrete. You are giving a straight information, straight away, either yes or no. Same way, marker beacon gives a discrete distance indication. How it provides? There are marker beacons. There are three markers installed on the straight line of the runway. One is called outer marker, middle marker, another is inner marker. These marker beacons are installed or at a fixed distance from the runway. Let us consider this inner marker beacon. It is at 1500 meter from the runway threshold. Same way, the middle marker, it will be around 4 kilometer from the runway. Outer marker will be around 8.5 kilometer from the runway threshold. So how they are providing the indication? Suppose your aircraft is flying above the outer marker, you will get a dot sound voice, and on the cockpit you will have a OM written on the PFD. OM written, OM, that is, you will not get any distance, measured distance indication. The moment you fly above the outer marker, you will get a long dash sound, long dash, and there will be OM written on the PFD. That's it. The moment you cross the outer marker, you will not get anything. No voice, no indication. The moment you reach above the middle marker, you will get alternate dash and dot, dash dot, dash dot sound in the cockpit, and will be written on the PFD. Then the moment you reach above the inner marker, you will come to know there will be you will heard a sound, t t t t, dot 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 sound you will get in the cockpit, and on the PFD it will be written IM. So it is a discrete distance information. The moment you get the long dash sound, that means you will come to know I am 8.5 kilometer away from runway. Right guys? Hey guys, come on man. Give a reply. You guys are silent.
Yes, sir. Yes, sir.
You see, what I'm getting, you guys are not understanding. You're not getting it. Raza. नहीं समझ में आया?
ऐसा थोड़ा सा कंफ्यूजन है, जैसे आउटर मार्कर है तो उस साइड पे अगर आएगा तो पीपीटी में क्या दिखाएगा? ओएम दिखाएगा।
बिल्कुल।
और जो इनर मार्कर रहेगा, लाइक ये जो व्हाइट वाला जो मार्कर है इनर मार्कर, आईएम दिखाएगा। उस पे आ जाएगा तो आईएम दिखाएगा। हाँ। और जो मिडिल वाला आएगा तो लॉन्ग डैश साउंड आएगा, लॉन्ग डैश एंड शॉर्ट डैश।
करेक्ट। डैश डॉट, डैश अल्टरनेट, डैश डॉट।
अच्छा, डैश डॉट, डैश डॉट। ओके, ठीक है।
Ajay, what is the doubt here, Ajay?
No, sir.
Okay, suppose Ajay, you are sitting in this aircraft, flying, coming for landing. You just reach in an outer marker. You will heard a sound in cockpit, dot dot sound, sorry, dash dash sound,
No, sir,
dash dash sound you will heard. So that means you will come to know you are almost 8.5 kilometer away from runway, right?
yes,
The moment you cross it, you will not get anything, right?
okay, sir.
That
Yes.
means there is no distance indication here, correct?
Yes.
The moment you reach above middle marker, you will get alternate dash and dot.
Dash dot. Yes.
Then when you will come to know, okay, I am at 4 kilometer away from the runway.
Runway.
The moment you reach inner marker, you will get dot 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 sound, and in the cockpit you will have an indication I am. So you will come to know I am just 1.5 kilometer away from 1.5 meter away from runway. So any moment I can land. So ILS is having three components. Three components. One is localizer, glide slope, marker beacon. Localizer's function is to give azimuth guidance, glide slope elevation guidance, marker beacon distance. I told you when I was when we were studying VOR, I told you if there is a system it will have an objective, it will have components, it will have principle, right? So component, now you came to know objective is to accommodate landing, or objectives to execute landing in challenging weather conditions, low visibility conditions, right? है ना?
Yes.
Okay. That is the objective basically. And the principle is DDM. What is the principle of ILS? Difference in depth modulation. What is that? Difference in depth modulation. So before proceeding to difference in depth modulation, the ILS works in a frequency 108 to 112 megahertz, odd frequency, right? Odd frequency 1182 112 megahertz, odd frequency. So each and every runway in the India is having a different ILS frequency. Basically it's a localizer frequency. You have to tune in your uh, cockpit, on the navigation control panel, you have to tune the frequency so that you can capture or you can establish on the ILS. Understood, Raza Sahab?
Yes.
आपका सवाल ये था, your question was there are different
Yes,
runways,
yes.
so how you, so every ILS system is having a different frequency, so you need to know the frequency and you need to tune the frequency. The moment you tune the frequency, it is a band actually, like you saw communication is 116 to 136 megahertz. So if you contact, if you want to contact Delhi ground, it is 1 to 1 decimal 9 megahertz, right? If you want to contact Delhi tower, 118 decimal 1 megahertz, है ना? So there are values 108 to 112. Correct. Between any value should be there. Any value will not be there. More than or not below that. Absolutely. Within that value. Correct. Okay. Understood. Okay. Now proceeding to the principle. We are understood about the component, objective. Now principle. Principle is difference in depth modulation, right guys? Huh? What is the principle? Yes. DDM, difference in depth modulation. Okay. So before proceeding to the principle of ILS, just I want to ask you guys something. Okay. Okay. Suppose there is a coil I am placing here. This is a coil. Okay. If I am providing AC power here, suppose AC power, and one more coil I will place here, guys. Okay. Now I will place uh, uh, iron or ferro material, electromagnetic material here in the between, in the center. Okay, right guys, in the center of the coil. So now if I am providing 50 volt here and 50 volt both the side, so will there will be any change in the movement of the magnet? No change. Okay. Now suppose what I did, I suddenly made it 150 red side, coil A, coil B. Okay, A side I have made the voltage 150. So what will happen so far? So say again so far. What change will happen? What kind of change will happen? What will actually happen, Ajay? Correct. it may be moved from A to B, or it may be moved from B to A. It depends on the coil winding actually, how the winding is there. है ना? Right? Getting me, guys? Yes, sir. Okay, this is the basic of difference in depth modulation. Now coming to the ILS, first we'll see localizer. Localizer. So what they have done, they have installed a localizer antenna at the end of the runway. You will have localizer antenna at the end of the runway. And there will be a BIM transmitted frequency, electromagnetic wave transmitted from the end of the runway, and that is divided in two parts. There is a modulating frequency of 150 hertz and another side 90 hertz. Two different modulation frequency transmitted in such an angle with respect to runway center line. Now we'll install same coil here, and again here. These two coils. This coil is sensitive to 150 hertz. This is sensitive to 90 hertz. Okay. Placing a iron core inside, and I will attach a single needle on the center here. Fine. Now, suppose my aircraft, what I did, I have tuned the frequency of the ILS here. What I did, I have tuned the frequency of ILS of the particular runway. Suppose my aircraft is towards left from the center line. What will happen, guys? The voltage on the 90 hertz sensitive coil will be more comparatively. Yes. So what will happen? Sofan, Raza. The core will move towards left. Yes. Along with the core, yes, the needle will also move toward left.
Yes.
So this is the way how difference in depth modulation actually functions. Understood, guys? Yes, sir. So suppose you are from the left of the runway, what will happen? Automatically the voltage, because these are the electromagnetic webs transmitted from the runway center line, and these are sensitive to 90 hertz, will have more voltage on the left side, and the indicator on the ILS needle will absolutely move towards left only, right, guys? Indicating that how much we are left from the runway. Same way, the moment you correct it, what you will do, you will try to correct, go towards right. The moment you come towards right, definitely slowly, gradually the voltage will be decreasing on the 90 hertz, and the needle will also come towards the center line. Is it clear, guys?
Yes, sir. But how we are receiving electromagnetic waves from runway to the aircraft?
How you are transmitting?
No, receiving. Like we are transmitting from the aircraft, like.
No, we are not transmitting. No. ILS inside aircraft, it is a receiver. It is not a transmitter. Try to understand. It is a receiver. Same way. Same way. Same way in VOR, there was a transmitter on ground. No. Guys, let's just listen to me. Please. In VOR, what was there? Where was the transmitter? Sofan. In VOR, where was the transmitter? Sofan. Ajay, where was the transmitter in VOR? Sofan, why you are not able to answer? I'm not getting it. No question you are answering. Okay, where is the receiver, Ajay? Ajay, where is the receiver? In VOR? in aircraft. So same way in ILS also there is a transmitter on ground and a receiver in
Okay.
aircraft. So what you need to do, you just need to tune the frequency and
Okay.
and the ILS will capture it. So how it captures it,
Okay.
it is a part of a little bit more technical detail we need to go. Hmm?
Yes.
Okay. So now this is the way it functions. Is it clear now, Raza?
Yes, sir.
Okay. Safan,
Yes, sir.
you're not going through the previous days, Safan. That is the point.
No, sir, I know the answer. Okay. But I thought that it would be good answer like that.
Nothing is big
I
here.
know it's not.
It is as easy as you open a bottle of water to drink. Okay, now coming for landing, Mr. Raza. You are coming for landing. So now
Yes, sir.
actually in ILS you only tune localizer frequency. Glide slope automatically captures, right?
Sir, where is the navigation panel on Airbus 320?
320 it is in FMCDU. You don't do any navigation from here. Navigation is there, but in if it is fail, if the MCDU is fail, multifunction and
Okay, this is standby.
yeah, it's a standby one. In 737, we have navigation separately. Navigation control panel is there separately. Same,
Okay.
it's look like the same way. It VHF it is written communication. It will be written as nav, so you can tune the frequency over there. Okay.
Okay.
So now coming to the glide slope path part. For the glide slope, the antenna will be at just near the aiming point. If you see, here will be the glide slope path antenna. Okay. How
Okay.
the localizer antenna transmits the frequency identically same way glide slope also transmit the electromagnetic wave. Example, now just consider there is a coil here. It is sensitive to 150 hertz. Okay. Another coil. It is sensitive to 90 hertz. Absolutely right. So you place a core inside. Okay. That's it. The moment you are above the glide path, desired glide path, we will have more voltage at the above coil. So automatically the needle will go up. So you need to come down to match the glide path. Understood, guys?
Yes, sir.
This is how the ILS works. So this is the needle which is indicating, there are two needles, one is indicating localizer, another is glide slope. So as I told you, now we will sum it, the whole function we can sum it. So these are the electromagnetic waves, green.
Sir, marker beacon only oral only.
Absolutely. Marker beacon gives only oral advisory, oral indication you can say. And plus there will be a indication in the PFD only written as marker MM, OM, IM. That's it. No distance will not come. It is a discrete distance you have to understand by your own. But nowadays, actually, the instead of marker beacon, DMA is co-located. The moment you tune ILS frequency, the moment you tune localizer frequency, the DMA will also automatically captured. What will happen? You will get DME distance indication here, right? Yeah, yeah, yeah. And the DU and DMA, you will get the DME.
Okay.
Okay. So what this is indicating, guys, this two line. Suppose you're sitting in this aircraft and you saw this kind of indication. What does it indicate?
Aircraft is left from the runway.
And little bit
Runway center line.
and little bit above, right?
Yes, and it is